magic jump cut. All right. So we have our lysosome. We have smooth and smooth. Oh wait, no. We have smooth and smooth endoplasmic reticulum. We have Golgi and Golgi apparatus. We have vesicles and vesicles. We have mitochondria and mitochondria. We have a nucleus and a nucleolus, a nucleus and nucleolus. We have a nuclear envelope, A lot of these things are shared here. There's a lot of things here that are shared. Now, it's the differences that I'm going to focus on right now. So, in an animal cell, we see centrioles right here, and the centrosome surrounding it is more likely to be noticed because the centriole calls attention to it. You might find some centrosome in a plant cell. It'll be there sometimes, but for the purposes of the Cambridge exam, centriole is what you want to call attention to when you're talking about differences between plant and animal cells. Animal cells are going to have a centriole, plant cells are not. That's what you're going to call attention to. Cam 4 plants aside. Now, chloroplasts. Chloroplasts are going to be present in plant cells, but not in animal cells. Cilium is singular. Cilia is plural. Those are going to be present in your animal cells. They are not going to be present in your plant cells. Flagella may also be present in animal cells. However, the only human cell that has a flagella is going to be the male sperm cell. That doesn't apply to Cambridge exam stuff, and it only applies to one cell in humans, and only to half the population-ish, so we're going to ignore that for now. Alright? Now, otherwise, the plant cell has more differences. We have a large central vacuole right here. Now, the plant cell, the animal cell may have vesicles, and it may even have vacuoles, but it won't have a large central vacuole. The large central is the key determinant. That's the key difference, large central. Now, other differences. A plant cell is going to have a cell wall. A cell wall, once again, is primarily composed of cellulose, which is beta-glucose in unbranched chains. Beta-1,4 glycosidic linkages, as we discussed in Unit 1, Now, we also have plasmodesma. Plasmodesma is a singular, plasmodesmata is plural, and we have those as communication points between the walls, little portholes in the walls between plant cells. Now, those are our major differences. Now I want to call out some differences. Now I want to call your attention, and I want to see if you can catch this. Play along at home, if you will. Is this an animal or a plant cell? Maybe I'll Photoshop in a little rotating timer here. Probably not. If I remember, I'll probably put a little message here that it's an animal cell. Is this an animal or a plant cell? It's a plant cell. Is this an animal or a plant cell? It's fictional. All right. So, let's see. All right. Now, let's talk for a moment about the calibration procedure for an eyepiece radicule. This is not nearly as complicated as all this. This slide is way too much. Let's actually take this to a much simpler level. I want you to play along at home. All right? So you're going to take a ruler. You are going to take, let's see, something I've got here. Expo marker. Well, we'll cut out the brand name. And I am going to measure my brand excluded marker in millimeters. So it comes out to about 135 millimeters. So this is 135 millimeters. 135 millimeters. I now know that this marker is 135 millimeters in length. So one marker equals 135 millimeters. This is now my conversion factor. That is my conversion factor. One marker equals 135 millimeters. If I want to measure something, not this ruler, and I don't have a ruler available, but I know that this marker is 135 millimeters in length. I want to measure something, say, this periodic table of elements. And I want to measure this, and I want to know how many millimeters in length it is. So this is 1, 2. To make my life easier, I'll just say it's 2. It's 2 and some change, but we'll just say it's 2. All right? So this periodic table is 2 markers in length equals 1 periodic table. Now I want to convert my periodic table to millimeters. I know that's 135. I know that in order to get my conversion factor, I need to be able to convert these markers in this periodic table to millimeters. So I want millimeters. I'm going to take this and I'm going to convert that into 135 millimeters per one marker. I'm going to multiply by 135 millimeters per one marker. I can cancel out markers now because markers is in the denominator. I divide markers by marker. And now I've canceled out markers. I am left with 2 times 135 millimeters. That is 270 millimeters equals 1 periodic table. I have now used a calibrated measuring device to measure a specimen. That's all you do. That's the procedure for calibration. The difference is the calibration procedure using a microscope eyepiece graticule is that you have a certain known quantity of measurement on the eyepiece graticule. The stage micrometer. The stage micrometer is a tool with a known length. It is your ruler in this scenario. Your eyepiece graticule is a film that you place over your eyepiece that has even tick marks on it that can change in number based upon what magnification you have on your in your magnification of your microscope. So if I have calibrated my eyepiece graticule based on the stage micrometer, I can tell how many eyepiece units are equal to how many micrometers of my stage micrometer. So if 1 micrometer of my stage micrometer is equal to 6 eyepiece graticle units, then I measure an object with my eyepiece graticule, and it is 12 eyepiece graticle units. I knew that one micrometer was equal to 6 eyepiece graticle units. My specimen was 12 eyepiece graticle units. 12 eyepiece graticle units is twice of the 6 eyepiece graticle units. That means it must be 2 micrometers in length. So that's all this is. That's what calibration is. Now, I'm not technically savvy enough to do some fancy cards in YouTube, like click boxes and stuff for this. So I hope you are taking notes at home, or you can watch this again. After all, that's what the bar on the bottom is for. Okay. So let's talk about linear magnification again. going to put my periodic tables away. Very important. If you don't know this equation, memorize it now. So, magnification equals image size over actual size. If I want my actual size, I can multiply both sides by actual size, cancel out my actual size. I can divide both sides by magnification, and that will give me actual size is equal to image size over magnification. Same thing. So, this effectively means M equals I over A, and A equals I over M. These are truth. These are truth. The truth is here. It's not out there, it's here. Sorry, X-Files. All right. So, that's the important bit. Now, scale bars. If you see a scale bar in a question, guess what you're going to measure? The scale bar. You are going to take the ruler, which you must have at any time. If you are taking an exam, you must have a ruler. Now, if you don't have your own ruler, you know I'll say this to you. All right. So, your scale bar is here. If I have a scale bar, that's the first thing I'm going to measure, no matter what. If I want the magnification of my image, I am going to do this. I am going to measure the scale bar. I'm going to measure the scale bar from the ruler to here, and that is 80. 80 millimeters. 80 millimeters is equivalent to 2 micrometers. So, if I want my magnification, I want magnification. I want magnification. My image size, I have measured as 80 millimeters. I measured this. My actual size is 2 micrometers. I was given this. These are my knowns. This is my unknown. I want my unknown. I have my knowns. My equation is this. M equals I over A. Plug and play. 80 millimeters over 2 micrometers. Now here's the question. Are millimeters the same unit as micrometers? No, they are not. But they can be equated to the same unit. Because I know that 1,000 micrometers is equal to 1 millimeter. And because of that, I can basically say that 1 millimeter are the same number. These are my conversion factors. I can multiply by this number. 1,000 micrometers per 1 millimeter. If I do this, I have millimeters in the numerator. I have millimeters in the denominator. Millimeters divided by millimeters cancels out millimeters. I have micrometers in the numerator. I have micrometers in the denominator. Micrometers divided by micrometers cancels out micrometers. I have 80 times by 1,000. That is 80,000. I have 80,000 divided by 2. That is 40,000. It is a unitless number. Magnification is a unitless number. Times 40,000. So that's how you would work through this problem. If you see a scale bar, measure it. Measure the scale bar. If you see a scale bar, measure the scale bar. The number next to a scale bar is the actual size of that scale bar. It's the actual size of the scale bar on the image, not the specimen. The specimen itself is not 2 micrometers. The scale bar is 2 micrometers. The specimen could be anything. The specimen is irregular in shape. There's strands and stuff there. I don't know where to begin there. That's crazy talk. So, let's talk about life for a moment. That sounds like an after-school special. Let's talk about the definition of life. All right. So life, for any living being to be capable of independent existence, it needs to carry out all of the following necessary functions. All of them. Nutrition. It needs to be able to seek out and obtain fuel resources. Respiration. It needs to use those fuel resources in order to produce energy. Excretion. It needs to remove the byproducts of respiration to prevent toxicity. Transportation. It needs to actively move itself or non-self matter from one place to another. Reproduction. It needs to pass on its genetic material to subsequent generations. Now, because a one-celled organism, unicellular organism, is the smallest unit capable of carrying out all of these functions, we can call the cell the fundamental and structural unit of life. So, as long as a multicellular organism is comprised of similar units, capable of all of these functions, it can be deemed a living creature, even if the entire multicellular organism cannot do all of these things. So, for example, a mule. A mule is often considered sterile, even though there are some cases where mules can in fact still give birth. Yes, it's true. It's out there, believe it or not. All right. So, mules, which are often considered sterile and frequently are, because they are made up of cells that seek out and obtain fuel resources, that use those fuel resources to produce energy, that excrete wastes, that actively move themselves, and the cells reproduce, the mule is still a living thing. Even though the mule does not necessarily reproduce, it is still alive. Because some human chooses not to have babies, does not mean they're not a living thing. Please, treat each other kindly. All right. So, that's organisms. Let's talk about organelles. Organelles are structures within cells that have a function, a specific function. So membrane-bound organelles have particular advantages to them. Cells can concentrate and isolate enzymes and reactants in a smaller volume, and thereby they can increase their rate and efficiency of chemical reactions. And the cells